Hello, everyone. I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle, excuse me, and break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Cracked Ice by Katie Splendor, and here are the rules. We have standard Sudoku rules apply, which means in every cell on the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is a box. We have digits along a lockout line must not be between the two end digits in the diamonds, which must differ from each other by at least 4. So the digits in the diamond on a lockout line must differ by at least 4, and the digits in between them cannot be in between them as digits. So for example, if this was 7 and 3, these 3 digits would have to be not between 3 and 7. And obviously it couldn't be the same digit as 3 and 7 because of normal Sudoku rules. So a valid example here could be something like 1, 9, and 2. Because all of these digits are not between 3 and 7. So that's an example of how lockout lines work. Black dots must separate digits in a 2-to-1 ratio, and not all black dots are given. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio between them. We also have x separate digits that sum to 10, and v's separate digits that sum to 5, and not all x's and v's are given. So for example, if this cell were a 3, this would have to be a 7 because it's next to a x, and these two digits must add up to 10. And this must be 2 because these digits are separated by v, which means they add up to 5. We also have light gray lines are palindromes that read the same backwards and forwards. So this must read the same going this way as it does going this way. I'll leave you to any obvious connections here in the we'll get to that in the solving. We also finally have light blue lines are region sum lines, where the border of the 3x3 box splits the line into parts with equal digit sums. So this is a region sum line. So this 8 must equal the sum of these digits, which must equal the sum of these 2 digits, which must equal the sum of these 2 digits. And that's an example of how region sum lines work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's go to this region sum line because that's pretty obvious to start. This is 8. These two add up to 5. And these 3 must add up to what that cell is, which is an 8. So this is 5, this is 8, that 4, this is 3. The only pair now which adds up to 4 or 5 is 1 and 4 because we can't have 2 and 3 here. So this is 1 and 4. 1 and 4 is in a 1-to-2 ratio with 2 only, so this is 2. And these 2 digits must add up to 8, and it cannot be 1, 7 because of the 1, 4 pair in the row, cannot be 3, 5 because of the 3 in the row, so this must be a 2, 6 pair. This then has to be either 1, 7. It cannot be 2, 6 because that would eliminate all possibilities for that cell. But it could also be 3 and 5 here. But we know this is a palindrome. So this 7 must be the same as this 7 because it reads the same this way as it does this way. Therefore, these are the same digit. Also, this palindrome means this has to be an 8 here. This can't be. This has to be 7 and 1 adding up together. We have this digit, which is in a 1-to-2 ratio with 2 other digits. The only possible combinations would be 2 with 1 and 4, or 4 with 2 and 8. But 8, we already have an 8 in the row, so this must be 2 with 1 or 4. Therefore, this 2 adds up with another digit to add up to 10, so it must be 8, and another digit adding up to 5, so this must be 3. So 2, 1, and 4 are all not between the digits in the diamond. And the digits in the diamond, so that means if you had a 3, you would guarantee that the 4 is in between that and another digit, because we can't have 1 and 2 already in those diamonds. So 3 cannot be any of these. We have to have a difference of 4 in the diamonds. That means this is a 5-9 pair. Remaining digits in row 5 are 3 and 6. Only the 3 is more than 4 away from 8. So, or 4 or more away from than 8. So this has to be 3 here, which forces this to be 6. 3 adds up with 7 to add up to 10. So the 7 is a 7 here because it's a palindrome line. If this was 6, it would have to be 4 or more away from only 1 or 2. But we have a 2-6 pair in this box, so this can't be 2. We have a 1 in this column, so this can't be 1 here. So this can never be 6. This is 2, which makes that 6. 2 is 4 or more away from 6, 7, 8, and 9. We can't have a 6 or 7 here, so this must be 8 or 9. And this digit is in a 1 to 2 ratio with another digit, which 9 can never be. 9 halved is 4.5, and 9 doubled is 18, neither of which are digits. So this is 8, which makes this a 4 to be in a 1 to 2 ratio with them. This digit has to be outs, cannot be between 2 and 8. That eliminates 3 through 7, and we can't have a 1 here, so this has to be 9. These digits are in a 1 to 2 or add up to 5, and we can't have 1 there, so it has to be 2 and 3. This can't be 2 because of the 2 in the column, so this is 3, and that's 2. 3 is in a 1 to 2 ratio with 6, but actually we knew that because of the palindrome line. Remaining digits in column 2 have to be 4 and 5, and 5 cannot be next to a black crop key dot. I didn't specify this was a crop key dot, but I've said it a lot, so. So, 5 can't be next to a black crop key dot because it's not double of an integer, and it's not, or a digit, and it's not half of a digit, right? If you have 5, you get 2.5, which is not a digit. If you double 5, you get 10, which is not a digit. So this must be 4, which makes this 5. So this must be 2 or 8, which is in a 1 to 2 ratio with 4. 7 can only be 4 or more away from 1, 2, or 3. So this is 1, 2, or 3. But if this were 1, the problem is the only digits not in between 7 and 1 are 8 and 9, and we need to have 3 digits here, so this cannot be 1 here. So this is 2 or 3. 2 or 3 is 4 or more away from 6 through 9 here. It cannot be 8 because of the 8 in the column. 2 or 3 is in a 1 to 2 ratio. 2 is in a 1 to 2 ratio with 1 or 4. 3 is in a 1 to 2 ratio with 6. So those are the possibilities there. This cannot be 2 and 8 or 3 and 7 because of 2, 3, 8 in the column. If this were 4 or 6, it would definitely be between 7 and the 2 or 3 here. So this cannot be 4 or 6, so it has to be 1 or 9 here, which must add up to 1 or 9 with this digit. Well, what possibilities cannot be between 7 and 2? It would be 1, 8, and 9, but because of the 1, 9 pair in the box, neither of these can be 1 or 9. So it would have to be 8 twice here, which is not possible. So this cannot be 2. This must be 3. 3 is in a 1 to 2 ratio with 6. 3 is not 4 away from 6 here. Also, there's a 6 in the column. So we have a 1, 9 pair here. Therefore, we must have 2 and 8 here because we already have the 1 and 9 accounted for in the box. So this has to be a 2, 8 pair. This cannot be 2 because of the 2 in the column. Oh, this doesn't have to be 2. It's 2 or 8 here. So this is 2 or 8. This is 2 or 8, which means this is 1. This has to be, how do you say it? in a 1 to 2 ratio with 1 or 4 here. So this does not have to be 2. Apologies for that. I kind of made a mistake there. This 1, 9 pair eliminates 1 and 9 here, so this is 4, which does make this 1, which makes this have to be 2, because that's the only digit 1 can be in a 1 to 2 ratio with. This 1 eliminates 1 here, so it's 4 and 1. This 2 eliminates 2 here, so it's 8, which makes this 2. This can't be 1 anymore. It couldn't be 1 because of the 1, 9 pair here, so this is 4. So if we had a 1 here, that would only add up to 5, and 3 unique digits can never add up to below 6. So this has to be 9 then. So this is 9, this is 1. This adds up to 13, so does these 3. If this is 9, this could be 1 or 2. If this is 7, it could be 1, 2, 8, or 9, but the problem is 8 can't be here because of 8 in the column. 9 can't be here because of the 9 in the row. So this has to be 1 or 2, period. This digit is the same as this digit, so we'll mark those both as red. This digit is the same as this digit. We'll mark those as green. So these add up to 13. Remaining digits in row 3 are 4, 5, and 9. This can't be 4 or 5 because of the 4, 5 in the box, so this is 9, which forces this to be 4 and 5. Okay. This cannot be 8 or 9. So again, this adds up to 13. This can't be 8, 9, or 7. This is at maximum a 6. Cannot be 5 or 4. Cannot be 3. So this is 6, 1, or 2. If this were 1 or 2, this would be 1 or 2 with it. So that adds up to 3. But this adds up to a maximum of 3 and 5, which is 8. So this cannot be 1 or 2. It must be a 6 here. Therefore, these two add up to 13 minus 6, which is 7. And the only possible combination here that works is 2 and 5 here. That makes us 4. Okay. This is in a 1 to 2 ratio with this cell. This has to be 6 or 8, which makes this 3 or 4, but this can't be 3 because of the 3 in the column. So this is 4, which makes this an 8. Therefore, that makes this a 4. This digit cannot be, it's the same as that, so it can't be, this has to be 4, 5, 8, or 9, but it cannot be 9 because of the 9 in the column. It cannot be 4 or 5 because of 4 or 5 pair in this box. So this has to be 8, which makes this 8. This 8 eliminates 8 here, so this must be 2. And the rest we're just going to have to know from just doing normal Sudoku. This can't be 4. Remaining digits in this left central box, this can't be 4 or 9. But we can only have 4, 5, or 9 here, so therefore this can't be 4 or 9. This is a 5, which makes this 9, which makes that 5. That leaves this digit as a 4. Rest of row 6 is 5, 7, 9, and 7 cannot be either of these digits, so 7 has to be here. This can't be 5 because of 5 in the column, so this is 9, which makes that 5. We have 7 digits in column 1, so this is a 1, 3 pair remaining. We have 6 digits in column 3, that leaves 1, 5, and 3. This can't be 5 because of the 5 in the box, so one of these is a 5. We have column 5 is 5, 6, and 7 remaining. Okay, this can't be 7 because of a 7 in the row. Column 7 has 1, 7, and 9 remaining. This can't be 1 or 7, so this has to be 9. which makes this not 9. So it's 7, which makes this 1. So this can't be 1 here. What are the remaining digits in this right central box? It's 1 and 2. This can't be 2 because of the 2 in the row, so this is 1, which makes this 2. We should have 8 2s now, which means we know where the last 2 has to be. It has to be here. Remaining digit in this lower right-hand box is 3 and 6. This can't be 6 because of the 6 in the column, so this is 3, which makes this 6. That eliminates 6 here, so this is 5, which eliminates 5 here. This can't be 5, and this can't be 5. This 7 eliminates 7 here, so it's 6, which makes this 7. Whereas the 5 in column 3, it has to be here. Remaining digit in column 8 is a 9. Remaining digits in column 9 are 1 and 8. This 8 eliminates 8 here, so that's 1, which makes that 8. 1 eliminates 1 here, so that's 3, which makes that 1. 3 eliminates 3 here, so that makes that 1 and 3. In row 9, remaining digits are 6 and 9, so that's fine here. In row 6, remaining digits are 5 and 6. That's fine. In row 4, remaining digits are, well, actually, we should do row 2. In row 2, the remaining digit is a 7. In row 4, the remaining digits are 7 and 9. 7 cannot be here because of the 7 in the column, so this is 9, which makes it 7. 9 eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 5 and 6. That leaves this digit as a 3 and this digit as a 5. And that's the solution. Fairly straightforward. Obviously, you have to be a little used to lockout lines to sort of figure this out pretty quickly. But everything's pretty straightforward along this. We also had this part, which made this rather trivial here, along this region sum line. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.